Alrighty, so in this video we're going to look at some past exam style questions on potential difference and the rules that it follows. So what is the potential difference across each of the lamps in the three circuits below? Write your answers next to each lamp. So in circuit 1 we've got an EMF of 6, we've got a potential difference of 2.5 across X. V, Y and Z are going to be the same because they're in parallel, and they're going to be the difference between 6 and 2.5, so 3.5. Moving on to circuit 2, we've got an EMF of 12, which means that the potential difference across X is going to be 12, because around that loop, potential difference has to equal the EMF. In the second loop, the potential difference of Z is going to be 12 minus 4 gives us 8. Moving on to the third one, if we want to do W, that's going to be 12 minus 3. And then for Z, it's going to be 12 minus 4, giving us 8 volts. Just all the time using Kirchhoff's voltage law here. What are the readings on the following voltmeters? So V1 is going to be 6 minus 4.3. V2 is just going to be 4.5 because V2 is measuring the EMF of the cell, which must be equal to 4.5, the potential difference of the motor. And V3 must also be 4.5 equal to the EMF of the cell. Okay. So in the circuit made of identical filament bulbs, each with 1 ohm resistance, a voltmeter is connected across AB measures 6, so the EMF of the cell is 6. What would the voltmeter measure when connected across CD? So before I get started on all of these potential differences, I'm going to write what the potential is at different positions. So at A, we know the potential is 6 volts, at B it's 0, so we can see the change of potential over the whole circuit. At C and F, the charges haven't gone through any components yet, so those potentials are going to still be 6. And at E and I, those are both directly connected to the negative plate of the battery. And again, there's no components in between there, so there's no change in potential. So next we're going to have to use the fact that the components are all identical, which means they're going to share the potential equally between them. So D is going to be halfway between C and E, and G and H are going to be 1/3 respectively. I would just caution you at this point, it's only shared equally if their resistance is the same. If they're not the same, the potential divider equations we're going to look at later on will help you with that. Okay, so the potential difference between C and D is clearly 6 minus 3, so 3 volts. G and H is clearly 2 volts. F and I is clearly 6 volts there all the way across. E and I, there's no potential change. D and I, we can see there's a difference of 3. And then D and H, we can clearly see there's a difference of 1 volt there. So 10 lamps are connected in series across a power supply. The potential difference of each lamp is 6. What is the EMF? Well, if they're in series, they're going to be sharing the EMF equally. So the EMF must be 60, so that when you divide it up by 10, that gives you 6 each. 10 lamps are connected in parallel across a 12 volt supply. What's the potential difference across each lamp? Well, if they're in parallel, it's got to be 12. Okay, so we've got a circuit here and it tells us the voltmeter, which we can see on the bottom right, reads 24 volts, and we've got a 40 volt EMF source. So the potential difference across the 10 ohm resistor must be 40 minus 24 gives us 16 volts. So what's the current going to be through that resistor? Well, we can use V equals IR, rearranged. We know the potential difference is 16, we know the resistance is 10, so we get the current 1.6 amps. What is the potential difference across the lower part of the parallel circuit? Well, that's got to be 16 too. The potential difference across parallel sections must be the same. And the ammeter we can get in the same way. We can do the potential difference, 16 divided by the total resistance, which is 40, gives us our current. Okay, and then final part, what are the readings on A1 and A3? Well, it's going to be those two currents added together. So A1 and A3 are going to be exactly the same. We take our two currents, add them together, it's going to be 2 amps. What is the value of R? Well, we now know the current going through R is 2 amps. We know the potential difference is 24. So if we divide those, we get the resistance, which is 12 ohms.